So in this chapter, we'll study about work, energy and power. So first we'll try to understand work, then we'll try to relate work with energy and power. So first let us try to define work. So in day-to-day life, a person sweeping the floor, a coolie carrying some luggage on the station, a person sitting on the chair and studying, or somebody going to his office, all are said to be work. But in physics, work is not just a mental or physical activity. In physics, we define work as W equals to force times displacement. So here we see that there are two factors. One is force on the object and second is displacement on the object. So now let us try to understand calculating work with the help of three examples. Also we will try to determine that whether work is a scalar quantity or a vector quantity. So in the first example, let us consider a block which is at rest and there is a force of 20 Newton which acts on the block. Now the block displaces by 2 meter and therefore I can write down work done as 20 Newton times 2 meter. So here you can see that since force and displacement are in the same direction and force and displacement those are vector quantities, therefore I am getting plus 20 Newton into plus 2 meter and therefore I get the answer as 40 Newton meters. Now here there is one very interesting thing to notice, that there was a scientist called James Prescott Joule who said that if a 1 Newton of force acts on an object and the object displaces by 1 meter, then that 1 Newton meter of work done can be written as 1 joule. So therefore this 40 Newton meter can be written as 40 joule, which is represented as 40 J. Now let us consider the second example. So in this second example, a person is trying to push a wall very hard, but the wall doesn't move. So if I try to write down the work done in this case, so let's say the force was very large and was equal to 500 newtons. So still the work done is equals to 500 Newton times 0 meter, which ultimately gives me work done equals to 0 joule. So the man has tried very hard, but according to the definition of physics, the work done by him is 0. Now let us consider the third example in which there is a block which is already moving from left to right. And there is a force which is acting on the block from right to left. Now according to sign convention, if I say that from left to right it is positive and from right to left it is negative, then my force becomes minus 20 Newton and the displacement becomes plus 2 meters. Therefore I get work done as minus 40 joule. Now from these three examples we can say that work done can be either positive, negative or 0. Now we see that there is no information about the direction of work. The positive work done only tells me that force and displacement are having same directions, and the negative work done denotes that force and displacement are having opposite directions. So therefore I can say that force and displacement are having directions, but work done is a scalar quantity.